All right. Hello, everyone. This is the first meeting of Cohort 5 of the textbook group on September 19th, 2023. And thanks, everybody, for saying hi. I will share my screen, and we will be looking at the Cohort 5 live meeting page. So this is kind of like the starting place for participating or joining Cohort 5. You can always click on somebody's icon on the top right of Coda and jump to the exact page they're at if it's not clear from looking at the sidebar. So here we are in the first meeting, and after today, the recording will be here, just like in Cohort 4, there's recorded videos. So I guess there's many places to begin, but is there any question that anybody wants to ask about any aspect of the textbook group? How do we even start and evolve it each time and make it fit for everybody who's doing this on their own time and who's coming at it from different angles? Varun and anyone else, you can raise your hand or however.
Cool. Just a quick question. Does the textbook include going through some of those extra notebooks on like active inference coding, like active inference from scratch, or some of the like programmatic implementations? Or does this mainly stay only on the theory?
Good question. The textbook itself, all of the code is in MATLAB. It's in Appendix C. And it is not a major part of the textbook itself. However, in the textbook group, people are bringing resources and other references. In the page called Code, you'll find several dozen implementations of active inference code, and we can certainly arrange sessions like just us informally, or trying to have the authors or other experts join to look over some code features if people are interested in this. But it's not a necessary or central part of the textbook. However, because the second half of the textbook is oriented towards application, especially, then talking about how you go from like a sketch of a system of interest and then use the recipe in chapter 6 towards actually designing the generative model. So for people who are ready and wanting to actually be working in code, then it's there and we can work on it. Esmail?
Yeah, I ask question. I want to know clearly about one very important term, surprise, and relationship with free energy. That can help me for good understanding this textbook. I think these two terms is so important.
Surprise?
Yeah.
Yes, great question. So, look, many questions will arise about all kinds of terms and about relationships. So here's just one way that this can be approached. So I went to the questions page, and in the search box, I'll type in surprise. Now, this is going to bring up a lot of questions because it's a very common term. But we could review the questions that have been asked and see if one of them directly asks what you're looking for. And if not, then it's like a huge act of service to add the question, because it's something that we're all curious about. And so this is how we kind of build our repertoire of asking questions. And also everyone is always welcome on their own time to go into the answers and discourse section and develop the answer, whether by adding material or by reorganizing shortly to answer your question directly. Surprise is about how expected or unexpected a given sensory observation is. So if you were least surprised by a sensory observation, you would have had like the most accurate belief. And so surprise minimization is equivalent to having the model with the maximum evidence. Surprise in and of itself, though, is often very hard to calculate. And so instead of calculating surprise directly, a tractable, optimizable bound on surprise is used, and that's called free energy. So that's definitely one of the key pieces, which is like if we had the minimum surprise model, we'd have the maximum evidence model. In the exact Bayesian case, that would be totally fine. However, in the high dimensional setting, it's not tractable to compute surprise. And so we have this optimizable heuristic with free energy and reducing the KL divergence. Susan?
Yeah, I'm particularly interested in actually mapping context. So is there a place that maybe scenarios are stored that that have been mapped or could be mapped?
It's a great question there. If it comes up in the context of a chapter, you can always beneath the questions in each chapter page, definitely people have talked about scenarios. And then also I will just add it to the chapter 1 notes here. But in the Active Blockfriends project, we have several dozen settings for cognitive modeling that people have worked to map. So I'll just add this link for settings for cognitive modeling.
Great. Thank you.
Cool. Anyone else have any just random thoughts, or we can explore a few other pieces?
Yeah, I am wondering, given that you've now run several cohorts for the textbook group, and so the knowledge base has already been established, but and you've had a few chances to try this out. I'm wondering what you're hoping each cohort will bring to either to the knowledge base, or how do you see each cohort evolving the study of these topics?
Good question. Definitely remains to be enacted. I'll just give thoughts, but not in any ranked or fine-tuned version. First, I hope that everyone who comes into the space synchronously or asynchronously can find epistemic and pragmatic value and learn about what's meaningful to them and be really in the game, in the arena with these topics as they're being developed. That would be a great first thing. And then for people who want to pick up litter in the environment and paint a nice wall and add a little bit of information on their way, it's unbelievably helpful for people to take an active stance towards their engagement with the coda. It can look like there's a lot, but it's not even a thimble in the ocean. And so people who really take an active stance towards looking at the material, and where there's a question that doesn't have an answer, just throw something out there. And when there's a question that has a bunch of information, just delete an empty row. There's some low-hanging fruit that simply inevitably improves the experience for everybody. There's always increasing amounts of augmented intelligence tools and language models, including with Coda, that we can play with, and so on. So even just adding small amounts of information or resources that people find relevant, adding new questions, just helping enact and embody that there isn't a final state of the knowledge base. Again, this is like a larger shared document than any of us would have made by ourselves on this textbook, but there's so many more directions to go. So I'm always kind of looking and speaking towards people who see affordances to improve what we have here and just do different things with it. And there's so many ways to go. There's so many unstructured notes for every page. There's fun things to do with Coda AI. There's fun things to do with synthesis, with linking to other work. In future textbook groups page, there's hundreds of lines of notes on different thoughts that people have had about how to make the material more accessible and applicable and rigorous. So just enjoying it wherever you're at as you're going through the group. And then if people would like to rejoin for future cohorts for this textbook group or for other projects at the Institute and do more, that's great.
Excellent, thank you. As a short follow-up, is there anywhere, either on the Coda or through some email link, where people can register themselves publicly, like a little database of people who are participating in the textbook group, and maybe as a way to advertise that I'm participating in this, and if anyone else wants to reach out to me, because I'm working on something that maybe you find interesting, here's my contact.
Sure. So one option for that is the projects page. Here's is kind of project based. Another option, I'll just make a I'll put it on this overview page. I'll just make a table for cohort 5 people. So if people want to add their own information, they can. So people can add at the bottom of the cohort 5. This is always a fun plot to look at as well. On the x-axis, it's people's like self-evaluated familiarity with active inference, from not familiar to very familiar. And then the y-axis is the computer science, biology, and math familiarity. It's all over. I guess one of the only trends that I see is that very few people say that they have higher than 80 familiarity with ActInf. Of course, all of these self-evaluation numbers, who knows what they really mean, but this reflects our textbook group through time. So people have just different backgrounds in math and computer science, biology, and all these things, philosophy, that weave together. So just staying in the game, and where there's uncertainty, like externalizing it with asking it will keep your cognitive load light and contribute to open science. So that's huge and fun.
Great, thank you.
Any other thoughts or questions?
I have one question regarding the structure of these text groups. So regarding you have multiple of these cohorts, are there any particular structure in terms of like organizing, for instance, these weekly meetings, like what to do during this time? Was it effective, or is that basically up to us to decide on like how to proceed?
I'm highly open to people who want to explore different formats. You can look at every single meeting to see exactly how it did happen. But that's not how it has to happen. It's not like we're locked in. It's just that we wanted to hit the ground running as soon as the textbook was available in 2022, and then just keep this opportunity around. Usually the way that we well, earlier on, we were just simply grasping with the textbook. And so we would often scan through the chapter, like during the meetings. So just working through the chapter and talking through the chapter. Where I would really love to see it is like people look at what chapter we're reading in the coming week. So it's alternating times. So usually not everyone can go to both on the given chapter. And also you can go to cohort 4 as well if you just want to go to, there's people are retaking it. We're all just taking it multiple times. So when the discussion starts, and again, this can evolve, but here's just one way that we can hear a lot of voices and get content and have like spontaneous things too. We'll go to chapter 1, for example, and I'll specifically look at the cohort 5 questions. It's all one underlying big table, just different views. This is just to make sure that if there's a new question that cohort 5 asks, that we'll be able to get to it. But like, let's just look at cohort 4, So then start with the questions, respect the effort that the person put in ahead of time to surface their curiosity, whether they're at the meeting or not, and try to go through the questions that are asked about the text. And then if people have curiosities arising, like during the meeting, I'm wondering about 4.3. It's like, just type it out. Like if it's typed out, it's forever. And then we have a place for the discourse. If it's just shot from the hip, it dissipates. Now it doesn't dissipate nowhere because we still can record it. And obviously we publish the transcripts of these textbook groups and so on. But like as curiosities arise, if you add them to the questions table, and then we can structure the discussions with just seeing with what's interesting, going to questions that have already been asked in certain settings, and other times going to new questions. And then in the time between the meetings, just people hopefully putting in the time to increase their situational awareness of the coda itself, read through the textbook. It's a many coats of paint situation. So there are parts that are going to be very dense with the use of the active inference ontology or very technical or things like that. So just time boxing and staying in the game. And then, what is the most effective synchronous meeting strategy? That's a good question. And then also we can make kind of supplemental meetings. For example, commonly some people want to do a math learning group that is like, some people want to focus more on the background and like the basic math, like reading equations, Bayesian statistics. And then other people want to do work on like more of like connecting the dots with the different expressions. So if people want to do more math, if they want to do more programming, if they want to be developing their project, don't let the institute be the rate limiting step. This is all up to people in their own learning journey and connecting to people here. And if you stay in the game over the coming 3 months, you will get a lot more familiar with active inference, even just with 1 hour per week. If you do more than 1 hour per week, you will get a lot more familiar with active inference. It's not all in the textbook, in this one 2022 short textbook, but this is a great landmark for the field as the first textbook, obviously, and it allows us to reference out to a lot of other cutting edge work. So the discussions are great for that, because we can kind of like be like, oh yeah, there's this like live stream happening tomorrow, or here's what this person said last week. And so it lets us kind of like look at how it was stated in 2022, while also bringing it closer to what's ongoing in the field. And if people, if in future cohorts, if people want to be a facilitator, it doesn't require technical expertise in active inference to be a facilitator. That's an option. There's many, many options.
Thank you for your detailed explanation. I think yeah, I do get that. There's plenty of room for trying to make this a really fruitful journey. Yeah, thanks.
Cool. Yeah.
I've got a question.
Mhm.
Where do you see innovative applications that may or may not be utilizing active inference that might signal us to kind of look at what is coming out, whether that be AI or augmented negotiation or social network analysis? Is there any particular cutting edge areas that are starting to get attention that would be interesting to coalesce around?
It's a good question. A lot of applications happen in the industrial setting, so they're not always shared like with the full methods and details that we would expect from like a scientific paper or like an open science educational project. So I think that's one fundamental unknown part. At least in the learning setting, there's a lot of exciting things with connecting innovative ways of modeling different systems, like we're seeing in active inference, and then the application work remains. Active inference is a very young field, and so that things that might be expected in a more mature field are not commonplace in active inference. And rather than interpret them as that as a dismal state of affairs, people who find that exciting and want to contribute there will find that even some pretty conventional work can actually have very impactful outcomes. I'll just link a few things. So here in the bottom, we have the active inference ontology. So this is one of the key features of what we develop at the Institute, which is like, we're speaking in English right now, but to a large extent, you could think of this as being a dialect of English, which is the active inference ontology. It's also been translated into many languages by experts. and it's a project that we work on every week with basically how to utilize the active inference ontology. And also I'll add to this page a knowledge engineering link. We've then used the ontology to analyze the literature and look at how terms change in their use per year. But overall, let's see if which plot is relevant here. But overall, we are talking about the number of papers being in the low hundreds over the last 10 to 15 years, most of them happening more recently, many of them happening through Karl Friston et al., but that also being increasingly decentralized. So just keep the finiteness in mind and look for the affordances to contribute, because there are many, many. So let's look at just the overall textbook. Oh yeah, we're just in the kind of the .0, the background, and just talking about the group itself. Chapter 1 and chapter 10 are textual overviews. They have no equations. They're kind of like bookends on the book. Chapter 2 and again, between now and December, we're going to be going through just chapters 1 through 5. But if you want to be also going to cohort 4 and going through 6 through 10, you can. And the authors very clearly say the first half of the book is like epistemic. It's about learning active inference. And so take the time to really learn what active inference is. It will make applying it easier when you understand what it really is. And then chapters 6 through 10 are exactly about the recipe of how you apply it. Now, it's not at the hold your hand guidebook stage yet, but we connect a lot of the dots here, and this is the direction that we're going in. Chapter 1 gives an overview, and it contextualizes active inference in relationship to a lot of other areas that people are interested in, that they study. Chapter 2 and chapter 3 are the low road and the high road to active inference. We're going to talk about this like a ton, but here's figure 1.2. Here's the low road and the high road, and they both meet at active inference. The low road asks how, and it answers it with Bayesian statistics. And the high road asks why, and the answer is basically self-observation, self-organization, self-persistence. And so active inference brings together this persistence imperative of the free energy principle, high road, why, with a Bayesian statistical implementation approach. That's the low road. So that's chapters 2 and 3, the low road, how, and then the high road, why. And then we get to the essence of active inference, which is the generative model. The generative model of active inference is like what is being built. This is what you have in hand when you have an active inference model. No generative model, just speculative. With generative model, you're talking about something specific. And so chapter 4 goes into some of the technical details about what these generative models are, building on some of the precursor steps that were covered in the low road and the high road. Chapter 4, generative models. Chapter 5 is going to focus on one of the areas that has the most empirical evidence and the most well-studied area, which is mammalian neuroscience. So as much of this work arose from human neuroimaging in the 1990s and early 2000s, there's a lot of work on human cognitive and behavioral science. And so that's the first half of the book. Context, how and why, what, and then where has it really been applied the most so far. But as we look at every single day, people are expanding the scope of active inference applications every single day. But the area it's been most studied is in mammalian neuroscience. That's the first half of the book. It hits hard, but that's where we're going to get to by December. And then just briefly, chapter 6 is a recipe for designing active inference models. So it's kind of like a procedure and a set of questions that you can ask yourself as you're designing a generative model, which is an important rite of passage in people's work in this area. They'll talk about that in chapter 10. Chapter 7 and 8 focus on two big families of generative models, which is generative models that treat time in a discrete setting, like click, 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 and then models that treat time continuously like a flow. Chapter 9 looks at the integration of empirical data with generative models, model-based data analysis. And then chapter 10, like chapter 1, provides context and revisits a lot of the more conceptual questions given what has been covered. So that's the main outline of the book. And they kind of, and those are the places that we'll go. But also because the questions take us everywhere. And people always raise questions at many, many levels. So if there's like, if there's an equation, or if there's some section that doesn't make sense, or it's not what you would have written, or you don't understand how they got from here to there, that's totally fine. I really encourage you just to continue working through it and just pass through the parts lightly that you don't feel expert on in the moment of your first reading or your 100th reading. Any other thoughts or questions? But yeah, it should be really fun. We're going to head into, for the coming 2 weeks, into chapter 1. So you can you can ask in the chapter 1 questions, you can just add them here into the cohort 5 section. Then they'll be tagged with cohort 5. You can go to just the questions overall, like chapter 1 questions overall. And it would be super, super helpful if you upvote the questions that you find interesting. That helps prioritize them for the discussion. And then also, once we have questions, like maybe 10 or more, or some number of upvotes, and then we feel like there's some questions where it's a very open discourse, but there's other questions where it's kind of like there is an answer. And in those situations, we can then go from the question to the curated thoughts on the answer. And then we can translate that into different languages. We can make short videos. We can make more bite-sized materials. I mean, there's just many ways we can go from there. But like, this is the real work, surfacing what people with different backgrounds and curiosities are curious about, respecting and encouraging all such voices, and then doing what we can to coordinate and do what we can with the answers, not to shut the door, because some of these topics are going to be just huge, open, intersubjective questions, or it will just gesture to a whole area of philosophy or some other area of practice. But there's been a lot of great questions so far. So there's a lot of value in reading what people have written over the years and reviewing the discourse, and again, hopefully modifying it if you're not sure, you can always like select text and then click this little arrow and do like a, you know, oh, I don't think so. If you want to, you can always do a suggest change, or you could add a comment. You'd say, oh, not sure about this, shouldn't that word be that? But if you're just adding a reference or connecting the dots or reorganizing the material that already exists, just the more the better. The more eyes that are looking at it and taking a deep breath and trying to evaluate it and interrogating it in the moment, that is so huge. And if it doesn't make sense, don't assume that it just made sense to someone else and that you just don't get it. Just, if it doesn't make sense, then that's your opening to ask that question, to write the follow-up. And this is a short video with Ali, who's not here now, but he'll probably join us some future times. If you listen to the recordings, you'll quickly become a fan of Ali's gentle scholarship. But yeah, we'll go into chapter 1, and we'll have the 2 weeks to discuss it, whichever one or both people join at. Again, chapter 1's a very prose-based chapter. It's not equation heavy. It brings up huge ideas though. And so then we'll just cruise through the discussion. Oh, ChatGPT, yeah. Oh, on one here in the equation section. So we translated all of the equations into LaTeX, plain text. And then here's using Coda AI to explain to high schoolers, write pseudocode, explain the variables, give philosophy questions, translate into different languages. Coda AI, I believe, currently uses GPT 3.5. But and then also perplexity.ai, you can upload a file. So I often have just uploaded the whole textbook and had discourse on the knowledge engineering project. Again, if people are interested in this, we are curating large amounts of the active inference information environment into fine-tuned language models with code and with visual recognition eventually, and some other features. So there's a lot of ways to go. So that's why we just stay in the game and have fun. Okay, any last comments? Yes, it is exciting. Thank you, Susan. All right, I will stop the recording, but thank you everybody till next time.
Thank you very much, Daniel.
Bye.
I really appreciate all this work that you're doing. I'm looking forward to the next meetings.
Thank you. Thank you. See you all.
Thank
Bye.
you.
Bye.